Good morning, grade 9. This is Ms. Teresa. This is a video guide for the Standardized Test Practice Chapter 2, Representing Motion. I hope you try to answer the practice paper independently first before watching this video. Question 1. Which statement would be true about the particle model motion diagram for an airplane flying at a constant speed of 850 kilometers per hour? So as you can see, I've already drawn particle diagrams over here. Particle diagram 1, 2, and 3. Why did I do this? Because this question is all about particle diagrams. And in the question, it was mentioned that we need to find something with a constant speed. So for particle diagram number 1, this will be at constant speed. How do we know that? Because the dots are evenly spaced. Okay, so this is constant speed. Whereas for particle diagram number 2, the dots are first evenly spaced and then the spaces are like becoming longer. So this one is speeding up, as we have discussed in class. This is speeding up. But then if the particle diagram looks like the particle diagram number 3, this is slowing down. Because at first the space is like long and then it becomes shorter and shorter, so this is slowing down. Now the question is that we are going to find which one is constant speed. What's the description of the particle diagram with a constant speed? The answer here will be letter C. The dots would form an evenly spaced pattern, and all the others will be wrong. Question number 2. Which statement about drawing vectors is true? So this question is about drawing vectors. Let's apply the process of elimination of the choices for this question. Let's start with letter D. All quantities in physics are vectors. Of course, this is wrong because some quantities are scalar quantities. Letter C. A vector is a quantity that has a magnitude but no direction. This will be wrong as well because we know that vectors are quantities that have magnitude and direction at the same time. For letter B, you need a vector diagram to solve all physics problems properly. This will be wrong. Some problems in physics do not require vector diagrams for solving. And then we go on to choice number A, letter A. The vector's length should be proportional to its magnitude. So this will be correct. Let's say, for example, if we have a 4 Newton vector, we will use our rulers to draw, let's say, 4 centimeters to represent 4 newtons. And if it's like 5 newtons, we're going to draw using our scales, using our rulers, and let's draw something with 5 centimeters to represent 5 newtons. Question number 3. The figure below shows a simplified graph of a bicyclist's motion. Speeding up and slowing down motion is ignored. When is the person's velocity the greatest? The answer here is letter B, section 3. As you can see from here, the section 3 part of the graph is the steepest. So if we have a steep line is equal to high slope. Okay, if the slope is high, it means that it is fast. So that's the only explanation for this question. Question 4. What is the average velocity of a train moving along a straight track if its displacement is 192 meters east during a time period of 8.0 seconds? So let's list our given first. The displacement delta x is equal to 192 meters east. And then we have our time interval, which is delta t. It's equal to 8.0 seconds. We know that the formula for average velocity, because we're going to look for average velocity, this is the symbol, is equal to delta x divided by delta t. Substituting our values, 192 meters divided by 8.0 seconds, then we'll be able to get the answer 24 meters per second, and the direction of the displacement is east. Therefore, our answer for the direction will also be east. So the answer here will be letter B. Question 5. A squirrel descends an 8-meter tree at a constant speed in 1.5 minutes. It remains still at the base of the tree for 2.3 minutes. A loud noise then causes the squirrel to scamper back up the tree in 0.1 minute to the exact position on the branch from which it started. Ignoring speeding up and slowing down motion, which graph most closely represents the squirrel's vertical displacement from the base of the tree? So if we're going to, let's say, draw a tree, the squirrel was originally up here, okay, at, let's say, 8 meters. And then it went down and stayed down for a little bit over here, and then it heard noise and it went back up the same level over here after like 2.3 minutes. So the only logical answer here for number 5 is letter A. Why? Because it went back up the same position after some time, and this is, let's say, 8 meters. All the other choices, since the y-axis is position, everything is position. Now none of the other choices give us the same level as the squirrel went back up the tree. So the logical answer here will be letter A. Question number 6. A rat is moving along a straight path. Find the rat's position relative to its starting point if it moves 12.8 centimeters per second north for 3.10 seconds. So the given here is the average velocity is equal to 12.8 centimeters per second. And then we have the time interval, which is equal to 3.10 seconds. Now it says in the question that it's moving along a straight path, so we are going to use the linear equation for motion, which is xf is equal to average velocity times time plus xi. So what is xi in this case? Xi, we will denote it as 0 meters. We will assume that it has started from the origin. Alright, so we are looking for the rat's position, final position relative to its starting point. Okay, so xf is equal to average velocity, which is 12.8 centimeters, multiplied to time, which is 3.10 seconds, plus the initial velocity, initial position, which is 0. So using your calculator, you'll be able to find that xf is equal to 39.68 centimeters. We will not be changing centimeter to meter because it wasn't required from the question itself. So this is the end of this video. See you in the next video. Good luck to your exams.